Welcome, welcome, one and all, and let's enjoy another special problem. Today we are looking at the Chapter 8 special problem, and as you know, the topic of Chapter 8, binomial as well as geometric distributions. So that's what I'm expecting to see. All right, so we have 100 students taking a 10-question multiple choice test. Each question has 5 answers. With only one of them being correct. All of the students are unprepared and must guess at every question. Okay, letter A, identify our random variable and justify, and then determine the probability distribution. Okay, so here we go. Letter A, X would equal the number of correct answers. Okay. Now, X, what type of random variable is it? Well, remember our 4 criteria, right? So in this case, I have 10 question multiple choice tests, so we have a fixed n, right? So that means it's not geometric. Each question has 5 answers, one of which is correct. So our probability of success is 1 out of 5 for all 10. They're guessing, right? So we have independence, we have fixed probability. We're meeting all the criteria to be binomial. Oh, and there's only 2 possible choices. Forgot that one. Okay, so X is binomial random variable. Okay, because two possible outcomes. Fixed probability of success. One out of 5. Fixed number of observations. In this case, 10. And we have independence because they're guessing. Okay, and then determine the probability distribution. So I guess we could do this by hand, right? X, P of X. Right. Remember, since it's binomial, we could see 0 correct answers, right? And we could go anywhere up to 10 whole numbers only. All right, so the fast way to fill this out is, of course, with our calculators. Oh, I forgot 0. And then just highlight list 2. And you could, manually enter the binomial formula, or the fast thing is, of course, the binomial PDF in the distribution menu. We have 10 trials, probability of success 1 in 5. Our X value is in list 1. So there we go. And then we get into some scientific notation here. Whoops, I skipped one somewhere. It's 9, this is 9.0. Let me see, which one did I skip? 7, 9 was, this one should be that one. Wow, I messed up very early on. Ah, here it is. This one was 0.302. Okay, went a little fast, but it's all good now. We all make mistakes, and that's one of the things I like to make mistakes from time to time, because sometimes students think that, you know, as a teacher, we never make mistakes, but we make mistakes. But the key thing is we should catch our mistake, right? As I'm filling this out, I go, wait a minute, I clearly made a mistake, because I got to the end of my list on my calculator, and I was only at 9, not at 10. Okay. All right, so there's our probability distribution of the number of correct answers for one student guessing on this quiz. All right, now, letter B. 100 test takers are taking the test, as we mentioned earlier. How many are expected to get each possible score? Well, pretty simple. This is for one student, right? So for 100 students, we simply multiply that by 100. Okay, so we'll just rewrite this. 0, 1, 2, 3, 4, 5. So multiplying by 100. And there's my lovely dog barking in the background. And you can see, even with 100 students taking the test, it's going to be pretty uncommon to see even a single student getting, you know, a C or better. So, and there we go. All right. Letter C. Richard is one of the test takers. Determine the number of questions he can expect to get correct by guessing. Okay, so a single student. Now we're not looking for the probability distribution of a single student. We actually have that already. We're looking for the expected or average or typical amount that we would get if we did this repeatedly over and over and over again. Well, we have a formula for that, right? The mean of a binomial random variable is simply equal to the number of trials multiplied by the probability of success. So in this case, we are looking at 10 times 1/5, so 2, okay? We expect Richard to get 2 questions correct on average, right? This is, again, expected value. It's an average, right? Many, many, many times he won't get 2, but he will average 2. Okay, letter D. How many unprepared students would have to take the test to expect 10 scores of 6? To expect 10 scores of 7, to expect 10 scores of 8. All right, so couple questions in one. All right, so 10 scores of 6. Okay, so we want to go back and see the probability of getting 6, right? Once we have the probability of getting 6 right, we simply have to solve for how many of those would need to take it to have multiple, that times the probability of 6 equal to 10. So probability of 6, I have it in my table here, 0.0055, but let's go ahead and just calculate that one directly so we have all the decimal accuracy. Oops. Binomial PDF, trials 10, X value 6. Okay, so there it is with more decimal places. So let's call that Y. Y times 0.005505024 equals 10. Okay, so 10 divided by that. There we go. We need that many students. Okay, so we'll round that. Well, we can leave it like that. We would need, on average, 16.52 students to take the test. In order to average 10 scores of 6. All right, let's do 10 scores of 7. Let's call this, I don't know, Z. So find the probability. Getting 7 right. And there we go. So, point. And do 10 divided by that. And there we go. So we're going to need, roughly 12,715 students, 16 students on average again. Okay, we need to do 8 as well. So 10 scores of 8. I don't know, let's call this, how about M? And of course, I'm using the binomial PDF, but you could do this by hand if you wanted. Just use the binomial formula. Okay, and 10 divided by that. There we go. Quite a few. Okay, and again, this is on average. So really, you're hopefully seeing that, holy cow, guessing on a test or quiz, even if it's multiple choice, not very likely you're going to be successful, right? This is just to get an 80%. Unlikely. So moral of the story, study. All right, next question. Letter E. Sarah also takes the test, and she wants to know how many correct answers she and Richard can expect to get all together. Okay, so this is actually going back to Chapter 7, Rules for Combining Random Variables. Okay, our rule for means. Okay, so in this case, we're going to do the mean of Richard plus the mean of Sarah. Well, they're both guessing. It's the same exact test, so they have the same exact expected value. So in this case, it would be 2 plus 2, or 4 questions correct altogether. Okay, again, on average. Okay. Letter F. What is the standard deviation of the difference between Sarah's and Richard's scores? Okay, so notice they threw in the difference there because this is the counterintuitive formula for combining variances. Again, remember, we only combine variances. We do not combine standard deviations, okay? So step 1 is actually calculate the variance, okay? We have a formula on our formula sheet for standard deviation, but remember, standard deviation is, of course, the square root of variance. So the variance of our random variable, again, single student, doesn't really matter, Richard, Sarah, any single student, they're all going to have the same variance and the same mean. It would simply be n times p times 1 minus p, right? Our formula sheet, of course, shows variance, shows square root, so it's the square root of that. So working this out, n is 10, p is 1/5, 1 minus p is, of course, 4/5, so that's going to be 40 over 25, and there's our variance. Okay, that's the variance for a single student. Now, we, of course, we'll be combining the variance for 2 students. I know it says difference, but again, variances add, okay? They don't subtract because it's every test taker involved in the computation adds more variance, adds more variation, right? From one test to the next. So even though we're subtracting their scores, we will still be adding their variances, okay? So x minus y, or x minus x, again, doesn't really matter. So in this case, 40 over 25 plus 40 over 25, we get 80 over 25, okay? So variance would be 3.2 questions squared. Remember, variance is square units. That's one of those tricky questions they like to throw at us. They'll say, what's the units on this? And a lot of students will miss it. Okay, but we want the standard deviation, so the standard deviation will equal the square root of 3.2 questions. Okay, so let's see. Approximately 1.79 questions. Okay. And letter G. Richard wants to know how many questions he will have to answer until he gets one correct. Until. So they've changed. It's not, hey, you're taking the whole test, right? It's, you're going to just go until you get one correct and count. How many is that? So yeah, my random variable has now changed. It's no longer binomial, right? Binomial, it's how many are you going to get right out of 10. Now it's how many do I have to answer to get one right. So the new random variable is now geometric. Because, of course, we still meet the other 3 criteria. I'm not going to relist those 3. We've just changed from a fixed number of n to how many does it take to observe a success. Okay, so answer his question. So how many on average will he have to answer to get one correct? Well, remember the mean of this random variable on your formula sheet is simply 1 over p. So in this case, we are looking at 1 over 1/5, or in other words, 5 questions. On average. So Richard will need to answer 5 questions. Keywords on average to observe his first correct answer. And again, it's really key to say on average, right? Sometimes he's going to answer the very first question right? That's going to happen. Sometimes it'll be the second question, sometimes the third question, so on and so forth. We could make a probability distribution of it right now if we wished. But the idea is on average, he'll need to answer 5. Okay, and that's the best we can do, right? We can say, oh yeah, if he does this repeatedly over and over and over again, 5. And that's the whole idea of probability, if you recall. This is a random phenomenon, but it does have a predictable distribution, and the distribution predicts that the average number of questions required will be 5. Now, of course, there's options to get any other number, any other whole number, other than 5. Well, and also other than 0. Remember, geometric can have a success with 0 attempts. Okay, so any other natural number. But again, the best we can say is on average, or we could give a probability distribution and leave it up to the reader to say, oh, okay, here's the whole distribution. All right, so hopefully this makes sense to you, and hopefully you're doing this before you take the Chapter 8 test, and good luck on that test. Thanks for watching.